Hello, my name is Pranay Agrawal. Welcome to this presentation on JUnit, a unit testing tool for Java. JUnit is a popular Java testing framework designed for writing and running unit tests. A unit test checks individual components to make components of the code, like a method or a class, to make sure they work as expected in isolation. The goal is to catch errors early in development before they become bigger problems. JUnit belongs to the XUnit family of testing tools, which includes frameworks like NUnit for .NET and PyTest for Python. These tools share a similar structure and philosophy, helping developers ensure their code remains reliable, easy to maintain, and less prone to unexpected issues. JUnit offers several key benefits that makes it an essential tool in software development. Let's discuss these benefits. First, early bug detection helps developers catch issues during the development phase, reducing the chances of bugs appearing in production. Next, automation allows tests to run automatically during build process, which saves time and ensures that tests are not skipped. JUnit also supports regression testing, meaning it ensures that new changes or updates don't accidentally break existing functionality. Finally, JUnit is great for test-driven development, or TDD. TDD encourages developers to write tests before writing the actual code, leading to cleaner, more reliable code from the start. Now, let's talk about the key features of JUnit. JUnit offers several useful features that makes testing easier and more efficient. First, annotations help structure tests. For example, @test marks a method as a test case, while @before each and @after each allow you to define code that runs before or after each test, like setting up or cleaning resources. JUnit also provides assertions, such as assert equals and assert true, which compares expected and actual results to determine if the test passes. It supports parameterized tests, which allow the same test logic to run multiple times with different inputs, saving time and avoiding duplicate code. Another great feature is integration build tools like Maven, Gradle, and CI/CD pipelines such as Jenkins. This makes it easy to automate tests and ensure they run consistently in every build. To summarize, JUnit is essential for ensuring that Java applications are reliable and maintainable by allowing developers to catch bugs early and keep their code clean. It also plays a crucial role in continuous integration workflows, where automated testing tests run with every code change, ensuring that new updates don't introduce unexpected issues. With JUnit, developers can confidently build and maintain high quality software. Now, let's move on to the demo of JUnit. This is a piece of code which I have written, which returns the grade based on the marks received by the student. So as you can see, if the student receives a mark grade in 90, he'll receive an S grade. If he receives a mark between 80 and 90, he'll receive an A grade, and so on. Now let's see how we can test this code. So now I've created another class called service test. Now in this class, I have several functions, and each function tests a different aspect of the code. Before each function, I have added this annotation called @test, which indicates that this function is meant for testing. Now let's try to understand this first function, test grade get grade as. So first, we create an object of the service class. Next, we store the result of getting the grade based on the marks of 95. So uh, based on the marks of 95, we should expect a grade of S. We should expect an S grade. In the next line, we use this assert, and the reason we use assert is we want to check whether the result obtained by the code is the same as the expected or the true result. So we are checking if the actual true result is the same as the result obtained from the code. Now to run this test, we can just click this button. As you can see, the test has passed. Now let's say I want to test all these functions simultaneously. So what I can do is I can click this button, run service test, and as you can see, all the test cases have passed, which indicates that my code is correct. Now let's try to change something in the code and see if the if we run test cases, are the test cases able to detect the flaw which is there in the code. Okay, now instead of returning an A grade, let me return a B grade for this code. On running the code, we see that the test grade A test case has failed, which indicates that the code isn't returning the correct grade for this function. The expected result is A, whereas the result obtained by the code is B. So to fix this error, we can just go to the code and then change this grade from B to A. On running the code now, we see that the test cases have passed. Now let's look at a different type of assert. So now this type of assert is called assert true. So in this type of assert, we are expecting that the output obtained by the code is true, and if it is false, then the test case will fail. So to test that kind of assertion, I've created a new function, the code called check even. It returns true if the number is even, and false if the number is odd. Now on testing this code, the input of the code is 100, so the output should be the expected output is true. So on running the code, we see that test case has passed. Now let's look at a new way of running a test case, which is called uh, test run test with coverage. So when I run this test, then when I run this test, I can see which part of the code has been executed. So the test case which I ran was test get grade D, and as you can see, um, this if condition has been executed fully, which indicates that which indicates that when the test case was run, then this piece of code is run fully. The green indicates that the code has been run, and red indicates code has not been run. So this has been executed fully. That is all for the demo of JUnit. Thank you.